Okay, so let's go ahead and take a look at the next couple of questions. I'm going to take this off from problem number 5. Then we'll see how far we go. I'll put that in the header, see, how far we get. So starting with question number 5, we are looking at something that's an application of what we call the angle addition postulate, which simply says that if you could take the angle on the left, YMA, and add that to the angle AMC, you would get angle YMC. So they're telling me that this entire angle right here is 170 degrees. So if I added these two pieces together, which of course would be 10x is plus 20, I should get 170. So it looks like I got 150 if I subtracted 20 from both sides. Maybe I should show that. And if I divide both sides by 10, I was able to find out that the value x is 15 degrees. Finishes my story, but keep in mind, it didn't actually want me to stop there. It says, what is the measure of angle AMC is actually my final answer. So AMC, I would want to find out what is 5 times 15 plus 1, which turns out to be exactly 76 degrees. Now, it didn't actually ask me, oh, actually it did say YMA as well. That's nice, actually. So 5 times 15 plus 19 would be 75 plus 19. So 75 and 20 would be 95. So I'm going to have 94. And I like the fact that we asked you to do both in that case, because now if you added those two together, you do in fact get the 170 we said. Okay, so question number 6. Sorry, that looks like a triangle, but that's supposed to be angle 1 and angle 2 are a linear pair. So as a picture, it's this kind of picture like here. Two angles that together form a line. And I'm telling you that one of the angles is 7x plus 18. The other angle is 8x plus 12. And if they form a linear pair, then together they make a line, which means they add up to 180 degrees. So structurally, it's actually very much like question number 5. So if we were to add those two together, you get 15x plus 30 is, again, 180. So that would make 15x if I subtracted 30 from both sides. And I got x is 10. What a super nice number that is, because 15 times 10. And so if I were to plug that in, 8 times 10 is 80, plus 12 is 92. And 7 times 10 is 70, plus 18 is 88. So those are those two angles, but remember, I wanted angle 2, so I could say then that measure of angle 2 is, in fact, this guy right here would be 92 degrees. Okay, cruising down to the bottom 2, these were called vertical angles. And one thing we need to remember is that vertical angles are, in fact, congruent. So I could take 13x plus 9, and I could set that equal to 15x minus 5. Let's go ahead and subtract 13x. There's a lot of little algebra problems in here. We'll add 5 to both sides. I've noticed that some of you are struggling with just the algebra pieces that go on here. And then, of course, if we divide both sides by 2, we get x equals 7. And in this case, that's actually what they asked me for. They didn't ask me for the angle, but if I were taking the final and I'd want to make sure that I'm doing things right, I for sure would double check that and plug that in. So let's see. So if x is 7, which is what I found, let's take 13 times 7 plus 9. So I got that this top angle is 100. And let's see, what is 15 times 7 minus 5? And let's find out, did we in fact get 100 as well? And the answer is we did. So that's looking pretty good. So this was vertical angles. And the same thing happens here. Those are also vertical angles. And the funny thing about this is this line right here didn't even matter. We didn't ever even need that other line. It was irrelevant. Vertical angles are always equal. So again, since these x's are on opposite sides, I'm going to subtract x from both sides. And I get 11x minus 10x is 1x. I'll add 1 to both sides, and I get 9, and then we're done. That's pretty nice. So 11 times 9 is 99, minus 1 is 98. So 99 minus 1, or 10 times 9 is 90, plus 8 is 98. So it looks like we did okay there. Okay, so off to the next page. Using our friend the distance formula. Now, I did mention that you could do this one of two ways, at least for my students. So we could look at it as the square root of x2, the second x minus the first x, so the second x being 5 minus the first x being -1 squared, plus the second y, which is -6, minus the first y, which is -2, and square that as well. And so if you took 5 and you subtracted -1, that's really 5 plus 1, which is 6. So we've got 6 squared. And over here, we have -8 squared. That's 36 plus 64, and that would be 100. So the square root of 100 would be 10, which is pretty nice. But one of the things that I mentioned, and really this is the same question, just back to back, just slight nuances there, is that whenever you take the difference of two things in math, we can actually just use this little symbol, which means change. So x2 minus x1 is really just the change in x. And y2 minus y1 is just the change in y. So you could literally do that. And so if you look at these two things, if x went from -4 to -1, it changed by moving up 3. And if y went from 0 to 4, it changed by 4. Now, you would get the same answer if you went this direction. I just find this to be easier. And so I got the square root of 25, which is 5. Personally, I find that a lot easier. Now, moving into 11 and 12, we'll just take a quick look at a little bit of Pythagorean theorem. So we have x squared plus 9 squared. Remember, it's a squared plus b squared equals c squared. And a and b are interchangeable. It doesn't matter if you do x squared plus 9 squared or 9 squared plus x squared, completely irrelevant, as long as the 15 is the one on its own. So here we go. So remember, we got x squared plus 9 squared, which of course is 81, is 225. And so I think I want to take the 225 and subtract 81 from both sides. So I got x squared is 144. And of course, that makes x the square root of 144, which I hope you guys know is 12. Now over here, this problem is not quite as nice. This one isn't quite as nice because you have a squared plus b squared equals c squared. But in this case, it's the first one on here where it doesn't do that because 16 and 36 add up to 52. Well, that's not a very nice number because the square root of 52 is not like all these other problems. You know, when we had the square root of 100, we got an easy answer like 10. But in this case, when I take the square root of 52, I get some crazy looking decimal, 7.211, which is fine. But really in math, we usually don't like this answer, that 7.211. We usually choose to rewrite it a little bit different because it turns out 52 is 2 times 26, which in turn is 2 times 13. Or in other words, 2 times 2 or 4 times 13. And although I can't take the square root of 52, I can take the square root of 4. So we could call it 2 roots of 13, or as some of the teachers do, myself included, a lot of times we refer to play and go fish, and that right here we had a pair of 2s, and then we had the 13 left over in my hand. So that gets us from problems 5 through 12. Hopefully that's good. I'll see you back in class. Bye-bye.